We are starting an organization called the CanSLAM Circuit. It is a multi-pronged solution to quite a few industry problems that we're having today, or at least we're hoping to fill those needs. And I'm just going to explain to you today a little bit what's behind it, what we're doing in order to make it of any kind of value, and then how this is going to be a reoccurring theme throughout time. So just to get started, introduce myself. I am Alex Hill-Stosky. I'm the manager of reality capture development and regulation at Eagle Engineering Consulting. And we're based out of New Brunswick, but we go where the wind takes us. We have operations as far east as Newfoundland, because you can't really go much farther than that. And then we are expanded south as far as we've had operations in as far as Florida. We've had operations as far west as Alberta, although I'd say that Ontario and New England kind of are our backyards, as well as, of course, Atlantic Canada. Lots of love. Co-founder is Karina Butterworth. She is an instructor at the Southern Alberta Institute of Technology, officially making this a very cross-country endeavor. She is also a PhD candidate at the University of Calgary, and yeah, co-founder of the SLAM Scanoff. So to give you an idea of what a SLAM scanner is, so there's quite a few different types for different functionalities and different applications. So they are very diverse in the fact that you can mount them on vehicles, you can mount them on backpacks, people, robots. You can pretty much do anything, attach them to anything that moves. And they have very flexible applications in where they can collect data, whether it's underground, inside buildings, inside small facilities, just kind of there's a few stipulations that need to be thought of before you start implying these particular types of tools. And of course, these are really paving the way for more improved decision making, more on-site familiarity, and provides a really high definition model of the information that can be presented in any given space or location. They are the foundation of digital twinning technology. Digital twinning is going to be a very big thing in the next 6 years. I think market estimates have it increasing by 1,500% in the next 6 years. You can go ahead and check the numbers on that one. And they are incredibly easy to use most times. Some of the older models were a little bit less so, but now they very much are kind of a turn it on, follow the physical instructions, and then push this button kind of thing. And of course, as a result, there are a lot of challenges with these particular units. So they can be very similar, but unique. All of the units that you see on the top row there, they all look the same, but they are all different. Not only in the guts that they use, although some of them are similar to others, but also in what happens behind the scenes. There are all kinds of models for all kinds of applications. Just because it's good for one doesn't necessarily mean that it's good for another. However, they're also very niche instruments in the fact that just because they are used in one field doesn't mean that they're not of value to another. So there is a lot of stuff to explore in order for a person to make a responsible choice as to which unit they're going to be going ahead with at any given time. Another problem is that, the performance metrics of these devices are non-uniform. They are published to I don't know, standards of the locale of the headquarters, I would assume. They just seem rather arbitrary. There isn't any kind of agreed on code as to what is represented in what increments. So you have to do a lot of conversion and puzzle solving before you actually figure out what the performance of the unit is compared to another. Sample data is another problem that's really difficult to overcome. So if I am going to be looking at a SLAM unit, I almost always need to contact the manufacturer to get a sample set, because very few people use these things, let alone are allowed to present their data to other people. We want to try to address this by making a centralized. We'll skip to that. So this is one of the problems of the industry. Coordinating those demos. We've identified over 30 companies selling SLAM devices, and there's 67 SLAM devices right now, which means that if you were to evaluate all of them, that is a very large endeavor. And good luck. If you don't have a team behind you, it's going to get exceptionally difficult. And of course, this all means that this decentralized information, it takes you a really long time to find an answer as to what device is good for you, what device is suitable to you, or performs the way that you expect. Google and AI copilots are not necessarily the best instruments for this. I've been searching SLAM instruments for years now, and I always find at least one more. And some of them have been around for years. So just because you do a Google search today doesn't mean that you actually search for everything on the market, because some of these companies are just burying the others. And of course, the other thing, exciting thing with these is that it unlocks a lot of potential for artificial intelligence applications, deep learning and machine learning. Right now, when it comes to point cloud extraction, a lot of it still is rather manual or semi-automatic process. And having more base sets available to developers so that they can look at these data sets and actually develop solutions for the instruments that's another thing that's kind of just lacking in our industry. Again, they still have to go through the process of contenting the manufacturers. And if it's an educational institution, it's very difficult to get an answer back. They have things to sell and they've got a limited amount of staff. It's not, not taking a stab. Fact of what it is. It just makes learning exceptionally difficult. And thus enters the CanSLAM. So the CanSLAM last year had 5 goals. This one has been expanded to add 6. So the first item on the list is to introduce Canadian industry to SLAM manufacturers. That doesn't mean geomatics industry. That means industry. Anybody who stands to benefit from these instruments, we want to make presentations at these industries and actually to promote these instruments. But number 2, encourage discussion and adaptation of their adoption in those particular industries, with providing goal 3, which is the warnings of what these instruments can do, what they shouldn't do, and things you need to watch out for and otherwise maintain when you're applying these instruments. We want to provide those free base data sets to purchasers, post-secondary institutions, machine learning and computer vision professionals and enthusiasts alike. Basically, anybody who can stand to contribute to this infrastructure, we want to make sure that they have as few boundaries as possible to gain the information that they need in order to execute their ideas. 5th one is to bring those SLAM manufacturers together. There are some phenomenal instruments that are coming out on the market right now. And like I said, most of them are very similar, and it's the insides, the software portion, that's the most unique. However, there are all kinds of really, really cool things coming out, and I would love for these guys to be more aware of what their competition is doing. So that they can either compete with them or work with them. I really don't care, as long as things continue to grow. And of course, further foster the development of SLAM and accurate and precise SLAM. The goal that was added this year is the adding of the AI downstream models, encouraging them to actually access these models, but also to make base sample sets that are suitable for their development. That would be retaining the raw files as well as the images, as well as the trajectories and the point cloud data, so that they can see how the information is collected, but they can also see how it's presented on the front end, so that they can better integrate their instruments. And just want to reiterate again, the CanSLAM, was reiterated last year. It's not a competition. We don't announce winners or losers. This is a resource. So there are no comments on performance beyond reporting of metrics. The life cycle of the CanSLAM, it is going to be an annual event. Kind of starts at the top. So first we convene and we discuss what instruments are available, the applications for them, things that need to be tested, evolving strengths and weaknesses. From there, we do an assessment of the resources that we have and the ability that we have to actually implement our designs. And then, of course, we design the courses and implement certain strains or characteristics that would be of interest to test the performance of these particular units in particular circumstances, while trying to keep it as general and broad as possible. Again, because we're trying to encourage multiple industry adaptations rather than just focusing on the geomatics industry. And of course, after the designs are thought through and penciled, we then establish those sites. We'll get into the details of that later. We then invite all the participants to come by one of the courses. Multiple courses is encouraged. And we do the collection. From there, the collection data is evaluated, and then we build by report. It is kind of a who's who of who participated, where the data can be found, general performance criteria, again, will be displayed later. And then, of course, we'll be promoting that data It will always be released at the GoGeomatics Expo first. So it's be released in October, end of October this year. And that'll be always the premiere of this particular these particular findings. The way that it's going to work, we have formed basically a committee or a conglomerate of institutions and organizations and individuals uh, to form more or less a council so we can start bouncing ideas off each other, how we're going to test things, what's available to us, what's of interest. But we're engaging the post-secondary institutions, specifically ones that are CBEPS or either CBEP certified or have been CBEP certified, to emphasize the application of geomatics technology inside of these systems. But it's a multi-pronged approach. Again, for the learning, getting the resource access to the students, showing and demonstrating the use of students today. So a lot of people are recruiting geomatics students out of universities, which is fantastic. But they're finding that when they hire them, they need to do a lot of training. They are very unfamiliar. They can be very clumsy with the equipment. A really quick solution to that is shift your focus to the colleges. If you need somebody to work on your instrument right now, you've got a better working foundation with a college graduate. For anybody that's not familiar to Canada, there is a difference in the United States to colleges and universities. Um, uh, yeah, our colleges are like trade schools, while the universities are more the broad education application. So yeah, to re-encourage that if you want the work done today, you're going to want a college student. If you want the work assessed and improved upon tomorrow, maybe the university student will be a better fit for that. Um, we want them to work in cooperation though, because we don't want engineers and field technicians to go parallel without crossing paths and understanding who each other are and what we're doing, and to foster that communication and to foster that growth. Once the universities have their courses selected, they are going to be establishing two per location. So one is an indoor location of a GNSS denied area. SLAM units, a lot of them are very reliant on GPS information in order to maintain rapid collection. The unique part of SLAM is that it can operate inside of GNSS denied area, simultaneous localization and mapping. So it can find its location once you give it a rough place as to where it is. So once these courses are built, the second one is the external course. The external course is going to be either a road course or mining, just an external environment to demonstrate the functionality of things like mobile mappers, and then give you, again, the feedback as to what kind of data these things collect in these particular environments. We are welcoming more academic bodies on board. The more academic bodies we have, the more testing courses we've got. The more testing courses we've got, the more applications we can look at. And of course, we're encouraging manufacturers to attend these courses. We don't want them to attend just one. We'd like to have them attend more than one, at least two, preferably three, preferably all. You'll notice there that there is an emblem for the RCN, which is the Reality Capture Network. They are not a partner of ours, but they are very much an advocate for reality capture development and responsibility. While they're not in partnership with us, they have agreed to guide people to us in order to facilitate this program a little further and to actually encourage these manufacturers who approach them almost on very much on a regular basis, asking them to test this equipment. They don't have the infrastructure, and so they've agreed to funnel them over to us to maintain a cyclical relationship of we collect the data, we present it at the GoGeomatics Expo, it gets circulated to everybody else, and everybody stands to benefit from it. The RCN, provided the data is of quality to them, will end up integrating it into their educational programs as well as their awareness campaigns to try to do the same thing that we're doing of encouraging responsible adaptation and growth. Just to give you a bit of an example of how it worked out last year. So the last year, the CanSLAM circuit went by the SLAM scan-off or the SLAMSO. This was The way that we did the evaluations of the units, we broke everything down into 10 fields, just to try to, again, keep it as general as possible while maintaining some kind of tangible report at the end that is of value to people that were attending or looking at this data. So first one being price. Everybody's curious about that one. In the first year, it was 1 year. The cost for 1 year. We're going to be reevaluating that for this year. I think it's going to be 3, possibly 5. Field time was another. So how long does it take from the moment that box opens to the moment you've closed it again and you're ready to leave? How long does it take to collect that data? Sometimes some time has to be deducted because we also encourage the developers to bring people on site to demonstrate for them to, two birds, one stone kind of deal. So yeah, we have to monitor them as they go so we can make adjustments for those social interactions that would not have happened otherwise. Post-processing time is another one of those. From the moment the data starts to upload to the moment the data is finished being downloaded from its export, how long did that take? Post-processing location, this was one where we just kind of had to figure out which way was up. This is whether it's cloud-based or locally based, or whether it's a mixture of the two. For that particular scale that you see there, local processing was on the high end. The only reason we justified that was for data security. If the data doesn't go anywhere, it's not as much at risk. Power required is another one. If you choose cloud processing, you won't have to use hardware as much. If you choose to do local processing, that story could change depending on if you're using LiDAR and photogrammetry or the mixture of tools that you're applying. Another metric was point cloud density, how many points per square whatever as the person walks through the site, to basically give you a feel of how much data is being collected per square meter, per square inch, if you're so inclined. Point cloud confidence was another one. So if you shoot a wall with a LiDAR scanner, in theory, that thing should be, a 1/10, a 100th of a millimeter thick because that wall is nice and flat. But it's not. Lasers don't really react that way. So there is noise to those point clouds, especially with SLAM units introducing all kinds of new factors to it. So you will find that point cloud confidence in SLAM devices tends to be, the point cloud tends to be a lot thicker for a wall in a SLAM unit than would be for a terrestrial or a more precise unit. There was also a comparison of primary control. So control establishment was done on site, and then LiDAR scans are built up around them for the one that was done last year. The internal ones this year are going to be very similar. But basically, first thing that we did was try to find those control points back inside of the scans to try to line those up with the environment and see how well the SLAM actually referenced the environment itself. The next one after that was the secondary control. So because we had those finite points, we were then able to build a scan around the scene. And we took that control scan, which was done using a terrestrial LiDAR scanner using conventionally accepted means, and then differencing the point clouds against that particular model, treating it as the ground truth. And then the last criteria was visual interface. SLAM scanners are fascinating. Some of them, the older ones, had no collection feedback at all. You just had to trust that you were going in and doing the job properly. And then you do the processing afterwards. Nowadays, you've got the visual feedback that you can actually see where you've scanned. And there's a lot of different applications there too, 2-dimensional or 3-dimensional. Does it update itself or does it not update itself? The difference there, if I walk through a site and then 10 minutes later, I come back into it and the columns are 2 meters apart. Does the computer automatically correct those and put them into place so that it represents the scene properly? Or do I now need to filter them out in my mind and try to figure out, okay, well, I've got that side of the column. Now I need that side of the column, but it's over there because it's over there in the other skit. It gets confusing. So just another criteria for that's of general importance. The scene last year was the TELUS Conference Center. This was chosen for a number of different reasons. One was the locality. If anybody had any questions, concerns, or wanted to challenge the course, it was right down the block from where the conference was last year. Well, sorry, not down the block, but it was very close to where the conference was last year. So anybody could go back in. The course itself was chopped into a few different sections in order to aid in analysis. But the course itself was roughly 186 meters long by about 50 meters wide. And as you can see here, it was chopped into four major components. Two of them were rather long hallways. One of them had many reflective surfaces and a lot of unique features, which we'll see in a second. One was a grand vault room with a lot of ceiling utilities that were very high up. So we wanted to see how well it captured distant objects. Um, Another one was a kind of a display hall with a few statues and a few fixtures that would be interesting to asset management professionals. And the last one is actually part three there. We considered that our straining area for reasons I'll explain. So yeah, we chose this one because of the fact that it was publicly accessible. You didn't need permission from anybody to go on site. So if any of the manufacturers had any questions, concerns, or wanted to challenge the results, they were welcome to go back on site and do it again. Hand it over to us and we'll take a look. As a result, though, it's public thoroughfare. We have no right to shut down the site as a surveyor or geospatial information collection professional. That's usually a consequence. That's a consequence of site that you have to deal with. You just have to work around what's there, despite needing everybody to stay out of your way. But whatever. And there is a high potential for change in these environments. So we wanted to see how those types of shifts in environmental features would cause problems in the model itself. Like I said, there were a lot of features inside of this building that were of interest to people like facilities management and buildings management professionals. But there was also a lot of these surfaces caused challenges for things like image referencing or SLAM alignment because they produced all kinds of noise and confusion. Elevation differences was another consideration here. So there were quite a few places where there were some vertical differences. We observed those vertical differences just to see how they reacted inside of the SLAM devices, because SLAM devices often have a difficult time reconciling the vertical. Yeah, like I said, there was lots of knickknacks and knackabracks there for people to look at, and various things for any one person to look at to evaluate performance to a marginal degree. But like I said, that straining location was the place where we wanted to break the system without making it unfair, basically providing the most difficulty possible. The plus 15 pedestrian bridge, or as we on the East Coast refer to them, sky bridges or skyways. This is a big challenge to SLAM units. So SLAM units in particular, if it's going by the LiDAR, it's either going to be edge matching or it's going to be geometry matching. But there's very little geometry in this space to speak of, and it's very repetitive. So it would be a lot easier for the particular unit to get confused as to where it is based off of the geometries that it's seeing. Another common orientation method is imagery. The reflections, and for the LiDAR is reflections. They add all kinds of extra information that's not actually there. So when you have a laser bouncing through a window off onto a fixture, back to the window, and then back to your receiver, it's just interpreted as being that far away from the mirror in a straight line. So you have a lot of echoes and you have a lot of ghosting. Those geometries can cause problems, especially because walking by a window, the geometry can change depending on where that instrument is in orientation to the window. Right, and the control network was established on site and made it available to everybody who was looking at these data sets, again, to validate the control that was done on site, to validate the control points that were set, and to validate the control scan that was built on those points. I forgot to mention on-site 3D and Fortress Geomatics were industry partners in this event. I regret not putting their logo up, but they were instrumental in the 3D scan. And that was the first exposure that the SATE students had to some of these laser scanning techniques. And it was an incredible learning experience for them as well. So I just wanted to put that out there. These were some of the results that came up in the last SLAM scan-off, or CanSLAM this year. Just a few graphic examples of the point cloud differencings that were done on site. These were not necessarily to scale, so this is not a visual references to how they perform in relation to each other. It's more magnitude of the reported values that were given, which were here. This is the final product that was presented at the SLAM last year. We are going to be presenting something similar, but the graphics are going to change just because participation will be up, and that will be exceptionally chaotic to view. So expect that to change among many other things. So yeah, why we're doing this is because of the fact that we want to create a manufacturer agnostic nexus for information regarding these units. Everybody's got their sales pitch. Right, wrong doesn't really matter. Everybody's looking for that unbiased place to get extra information or to shoot other ideas off of. And we would like to be part of that solution for you. We want this to be a learning and selection resource, as I've stated a few times over. Just the ability to access this information, to know the performance that you're going to get before you apply it or even spend time chasing it, is going to save you a lot. Yeah, once again, creating these common data sets for AI integration, training it on one, perfecting it, but then finding out why it doesn't work well in another. It's critical to the process. And without these types of resources, there is a certain amount of stagnancy that exists just because of the fact that the information can't get downstream fast enough. Again, we want to emphasize the students that are coming out that have these skills. It's incredible that there is insane demand for workers, but all the academic programs are dying. Sorry, not all of them, but many of them. York University was one of the universities that we had invited over to be part of this because they are a CBEP certified school, but they don't have any undergraduate students left. That's incredible. Certain circumstances abound, but schools are losing. We're losing schools as well as students, and it's time to start encouraging them all to come back. And of course, yeah, make those students more adept at what they're getting themselves into, so that hopefully one of these days you're going to hire a student, you're going to ask them if they know how to use a system X, and they're going to look at you with a light in their eyes, saying, "Oh yeah, I used that 2 years ago. It was a lot of fun. We did this, this, and this." So that is the SLAM scan off in a nutshell, just kind of what we're up to and what we're looking at for our applications here. If you like what you're doing, if you like what we're doing, I invite you to look at the results coming up in October at the GoGeomatics Expo, October 20th and 30th. To follow us on social media, and of course the UPC code there is what you can be using. Of course, engage with our content and encourage distributors, please. If you're looking to buy an instrument, ask them if they're partaking in the event to encourage them to submit data on your behalf for the next time you come back around. Of course, we're also looking for volunteers, lots of volunteer opportunities there. Gives you experience with industry professionals if you are a student. Also gives you a really big chance to just engage with industry members and other people who are passionate with this technology, and to build your foundation in things like in the robotics geomatics merger. We invite participation as well. If you have a unit that is either for sale now or is going to be for sale in 2024-25, we would encourage you to get a hold of us so that we can put you into the showcase. And of course, sponsorship is always great. We want to put out educational material. Right now, it is a 2-person show with about 10 people interested who have not been onboarded. But all of this is going to take time and money. So any help we can get would be appreciated, even if it is just something like half the cost of what it would have taken you to collect this information on your own, would be greatly appreciated. If you have a scene for us as well, again, we would have to be accessible at any time, but yeah, there's lots of places to scan, and we would love the chance to play. If you'd like to see the data from last year, it is available at the Eagle website. So just go to eagle-eac.com. On the top right corner, there's a SLAM icon, and that is where the data from last year's set can be found. But that is it. So thank you very much for your time. And again, thank you to John and to Tim for hosting. And yeah, if anybody has any questions, I'll be more than happy to field them.
I love the logo. Whoever came up with that, laser beavers. That's it's pretty good. It's pretty good.
Thank you. Yeah. I tried to go agnostic though. I once I put a picture of a particular unit last year, and that didn't go over well. So
Okay. I noticed they're green lasers, so they may be bathymetric enabled. That's cool. Um, just one quick question, Alex. Um, with respect to SLAM algorithms and so forth, we've looked around a little bit at open source algorithms. Do you envision having resources to talk about open source kind of materials and evaluations? Where can you get it? What's out there? As well as, of course, the vendor specific, somewhat high end type of algorithms that are typically proprietary with their gear.
yeah, absolutely. What a great idea. It is that would definitely be the educational component. Learning what it is, getting your hands on it. We have quite a few university students that have already tried building their own SLAM units successfully.
Yep.
Um, and yeah, they all found it to be quite the learning curve. So whatever we could do, absolutely. If anybody wants to volunteer their time to build that particular component of it, I would love to see it. Absolutely.
Yeah. No, I think SLAM is one of those technologies that has as they say, game changers, etc., has come
Yeah.
along and really revolutionized, especially as you described in the GNSS deprived areas or underground and so forth. We do have a question here for you. What is your personal favorite SLAM scanner?
You can't ask me
Well, that's
that.
I just read the questions, Alex.
Okay. Well, okay. Yeah.
I guess I put you in a bad spot with this
No.
generic
Well,
approach you're using.
yeah.
Rather,
Okay. So the one I admire the most wasn't even a manufacturer. So Kuden Artisans was a company that participated last year. They're a SLAM company, but they don't do SLAM devices. They do SLAM hardware. So
okay,
sorry, they do SLAM software. So
okay,
the development kit that they made was basically just a thing to get you started, spark your imagination, and then you come back to them and say, "Can you put this, this, and this on it?" And they say, "Yes, I can," and then they build you a little something. That one was I admired that because it very much it's custom. You can't go wrong. However, things like the Navis VLX are impressive. They are the fascination of me and the bane of most land surveyors I know. You can't put the data in a black box and then tell me to trust it. Like, I love that. I love those exchanges just because of the fact that yeah, there's lots of questions out there. But favorites, good grief. The Exon and the Emerson, I love them both because they're very platform agnostic. You can put them on a backpack, you can hold them in your hand, you can put them on a drone, you can put them on a car. Like
yeah,
so, yeah, my personal favorite. Um, I'm going to be a little more political than that.
understood and well answered. Um, so I guess we're probably going to continue our break. So great job, Alex.
Oh, thank you.
Very exciting initiative, and I hope other academic institutions do jump on board. I noticed, the institution that I'm associated with is not there, so I'll be talking to my academic colleagues about the fact that we should be there, and all of your advice regarding the academic situation, obviously concerning to the industry, and what can we do to turn it around to get people, more interested in geomatics because, I think the opportunities have never been better than they are today and moving into the future.
Right? Yeah.
But
Point clouds. Yeah, they sell themselves, whether it's recruitment or conferences. You put them in front, put a point cloud in front of them. Ooh, what's that?
that's right. Well, now kids can do it on their iPhone, right? So.
Yeah, yeah, it's good fun.
But maybe we'll pick this up in another 10 minutes or so in the panel discussion and keep it going. So
Looking
thank you
forward to
again,
it.
Alex. Very informative and great initiative you got going there.
Great. Thank you very much. Thank you for your time.